Hi there, today we're going to continue with this part here, part E and part F. I already talked about it already, theory. So we're going to see how these things come up in questions, past questions, right? In your acid-base titration and basically how to plot the titration curve, okay? We call it the titration curve. I told you there are 4 types. Here, strong acid, strong base, we've done this. I was doing weak strong acid, weak base, with doing weak acid and strong base. Remember now, the question was on ethanoic acid and your NaOH. Okay, so today I want to solve all the questions that are on there. Okay, so now let's go back to the question we have. It's on page 35, I think. 35, huh? This is the main notes. Remember now, all these things, I plot this graph for you today, right? And I make some mistakes, of course. Now here, this is the graph, right? So remember the pH jump for weak acid and strong base, you need to know is from 7 to 11. This is very important to see. This is the pH, okay? So 7 to 11 is a pH jump, because the pH jump, right? So memorize 3, 7, 11, no problem. Now, so this is a graph you plot, the one in blue, okay? So I made a mistake here, okay? It's on here. So now this is a bad graph. Should show only one continuous line. They want one continuous line, okay? So now let's look at the questions that is here. Right? Use the data to plot a titration curve, see, on a graph paper. That's what we did, isn't it? So state the pH range at the end point. Of course, the first question here, pH range is 7 to 11. All right, and explain why pH changes so rapidly at the region of the end point. Why not? Answer is because a small volume of NaOH, because they will add NaOH into the acid, isn't it? A small change, well, they change here. Change of NaOH added before and after the end point causes a large change in concentration of H+. Okay, or you can say therefore a large what? Large pH change. Yep. So also that means a large color change. Okay. So this one answer already. Calculate the initial concentration of your ethanoic acid. All right. Now it's of course to calculate the initial concentration. You can start from here, or there are 2 ways. You can start from here, or you can find the end point. Now the end point, which is commonly one here. All right. Remember, I told you you take the last 2 points before the jump. Okay. Right. The current today was 8.8. Isn't it? You trace down here. Well, this is the volume here, 8.50. So this is the end point, right? So you get the end point here. Here is the equation. 1:1 mole. Of course, this is a CH3, COO, plus minus plus water lah. Okay. So this is the, you want to find the constant, the molarity, isn't it? So it's the volume used. This is a volume found from the graph. This is the concentration. Then you find the number of moles of your NaOH. That's all. From here, this number of moles of NaOH. Okay, NOV, this is the one here. So obviously, it's the same. The number of moles of acid is the same. Right? So this is one here. Number of moles of acid here over 10. Why was 10 cm cubed? Isn't it? 1,000 is equal to this one. Means 0.0850 is the answer for the initial concentration of your acid. That means before titration. Using any suitable pH value, calculate the Ka. Okay, now you can use the pH to calculate, right? Because why? pH is equals to, right? pH is equals to what? Equals to pKa, right, plus log base 10 concentration of, well, the salt over acid. Okay. Now the best, of course, is to use halfway. So normally most questions they ask about halfway. See, now this is the 8.5 here. I'm going to put red pen now. You can see better. 8.50 here is the end point there. Okay. Right. This is when all the acid and base are finished. Now, after you see why the equivalence point is for 8, why not 7? After you see why. Okay. So here 8.5 means halfway, or 8.5 is 4.25. Right. It means 4.25 here somewhere. Right. It means this halfway here is when the concentration of your excess ethanoic acid, this is untitrated, is equals to the concentration of your salt, right? Halfway, okay, equals. Now this is very important, as you can see, right? So you can find here, The pH is about the same, 4.25. Let's say, okay, this is the answer we got. Okay, now so the pH here, right? So we got here. So midway, the volume of midway titration is 4.25. The pH is also 4.25. So no coincidence. So it's one here where the concentration of the salt, I put blue, concentration of the salt equals the concentration of your unreacted acid. Okay, so these two will cancel. Okay, so pH equals to pKa. See now. Okay, so very simple then. So pK, you just use your K, so inverse log, anti-log is the answer already. Okay, quite simple, right? So this one is a very commonly used halfway. Halfway is when the total amount of unreacted acid or the excess acid over the amount of salt formed, which is equal. This is the midpoint of the titration. Okay. Now, why in this case here? Why in this case here the pH is not 7? Right? Like if it's strong acid, strong base, let's see here, right? Strong acid, strong base. The first one, okay. See, right? This strong acid is a HCl. This is your annuation, okay. Right? The equivalence point, it means the end point, end point, which is 25, is equal to the equivalence point, is pH 7. Why for the weak acid and strong base? The equivalence point, the end point is not 7, but it's 8. It means it's a bit alkaline, 8.722. And why? Of course, if it is for, okay, this one here, right? If it's for, actually, there's not here. I don't have it here. I check the day, I don't have it here. Now, if it's for strong acid, weak base, okay, I have one here. Actually, that day we did. Okay, I forgot about it. Strong acid, weak base. Here. Okay, see strong acid, weak base. Now this is weak base. Oh, there's one here that I say ammonia. Okay, yeah, but if I takes out in this way, you see, weak base, ammonia, and your HCl. See, the pH change, okay, right? It's halfway here, right? It's less than 7. That means this is the equivalence point. Equivalence point means the pH at the end point. No, it's the equivalence point. Equivalence point. Okay, it's about 3. Okay, now sorry, 3. About 4 to 5. Let's say 5, halfway. Okay, right? It's a bit acidic. Why? Why for strong acid and strong base is neutral at the equivalence point, pH 7. Why for weak acid, strong base is about 8. Why for strong acid, weak base is about 5. Well, because the salt form are able to hydrolyze now here. See, I've got types of salts here. So if it's neutral salts formed from strong acid and strong base, the pH is always 7 because the salts do not hydrolyze. Means that the salt don't react with water. For example, NaOH, okay, strong base plus HCl. You want NaCl, which is the salt. Water is water lah. So NaCl, right, will dissolve to give you Na plus and Cl minus. So Na plus water, no reaction. No reaction. That means they do not hydrolyze. The keyword is hydrolyze. Cl minus plus water also won't hydrolyze. That means that they won't react with water. Okay, so that's why it's pH 7. Now, if it's a strong acid, like HCl, and a weak base, the salt form. For example, this ammonia and HCl. You form what? Ammonium chloride now. Okay, so at the end point, when you have ammonia titrating with HCl, where at neutral point, where all habits no more, get only ammonium chloride. Now this fellow here, right, is able to dissolve in water to give what? To hydrolyze, give NH4 plus Cl minus. Now this one won't react with water, but some will. NH4 plus is able to hydrolyze with water to give what? To give NH3 plus H3O positive. No, acidic, right? It's a weak acid. Go forward. See now, the ammonium salts are weak acid. That means this is formed. It won't go back easily. Right? You found a bit. So this is the pH is less than 7, around 5. See now. Now, if it is alkaline salts, it's formed from a weak acid. For for example, ethanoic acid, okay, plus sodium hydroxide. So if you titrate this one here, you get what? Your sodium ethanoate plus water. So at end point, habis, no more. This one is it. Now this salt is able to, first of all, ionize to give you your ethanoic ion plus Na plus. This one also is, this one is neutral. But this fella, see now, this fella here, able to hydrolyze, this is called hydrolyze in water. It means react with water. Okay, so I give you this one here, this one here. Now this is a weak acid, it won't go back so easily. So there's a left behind amount of OH minus, you know. See, that's why it's alkaline, a bit alkaline, means about 8 or 9. See now. So the equivalence point, that means the pH at the end point is not 7, unless it is a weak, strong acid, strong base. If it's a weak acid, strong base, the equivalence point is above 7, means 8 or 9. If it's strong acid and weak base, the equivalence point means the end point pH is below 7, is about 4 point something. Right? So we can see because it's hydrolyzed or ionized easily. Okay? I won't talk about all these things now. Let's go quickly now to all the questions that they want to talk about. Okay? All this, how to plot this kind of graph. Okay? Now the first one, of course, is here. Right? They say ammonia, pH of 0.2. We done all this before already here, but I left this part undone because you can't do everything one time. So the pH of pure ammonia solution of 0.2 moles is 11.3. We say why? Because the weak acid are weak base, partially ionized. Okay. Now here the question is 20.0 cm cube sample of this as 0.2 moles of ammonia. So I put down weak base to remind yourself, was titrated with 0.1 mole per dm of HCl on the following axis. Sketch, right? Not plot. Now plot means perfect. Plot is for paper 5. How the pH changes during this titration. It means as you add in something, of course, you add in HCl. So here, volume of acid added is HCl. So here is ammonia. Draw the diagram. Right? This is the burette here. Okay. So this is ammonia, right? So before you put any acid here, what is the pH? 11.3. So you sketch it, put line here. The minus here for this, 11.3. How the pH changes this? Okay. Now I told you already to sketch the graph, you must know number 1, end point volume. Okay. Number 2, pH at the beginning. It means before you add anything. 3, pH at the end of titration. 4, the pH jump. Okay, at end point. So of course, in this case here is a weak base and strong acid. Of course, it's 3 to 7. Okay, so this one at the beginning is how much? 11.3. Okay, at the end right now, because it's a strong acid, right? I'll show you how to calculate. Okay, some did ask, but I'll show you how to calculate because it came out in the recent one. It came out. Okay, hold on for a second. Okay, so here you can see I got the thing here now. How to calculate the last part, because they did actually the marks wasn't given. That's a very simple one. Okay, now you can do it very simply like this, right? Let's say now where's the end point? Obviously, this is a 1-to-1 ratio now, yeah, because ammonia plus HCl give you what? Ammonium chloride, right? The equation is what? 1:1. Okay, so if the volume of this is the volume of your beginning, right? Ammonia. This is the molarity of this one here. So this 2 times more than this, of course. It means the end point will be how much? Will be 40. You can calculate you want to lah. Okay, I want to go. Okay. Okay. So the end point is 40. So I know that the end point is 40. Okay. Right. So it's the end point. So I know that the beginning is 11.3. So how can I find the end at 60? Because they put at 60 here. So can. So let's say now before and after. Okay, I'm going to find the concentration of OH minus before and after. Now before I add, I mean here, right now here I add 60 cm cube of acid. Okay, right? Originally here got how much of ammonia? Here got here got 20 now. Okay, okay. So now before I add in the ammonia, or before ammonia was mixed here, the origin, this is HCl, by the way, this is HCl. Before it reacts with ammonia, this is the number of moles. And after this is the number of moles. So 0.1, which is the molarity here, okay, times the initial, okay, initial, where's initial? Okay, initial is 60, okay, no, that means, let's say, okay, 60. And then after reacting with the ammonia, the total volume is what? Is 80, yeah? So before and after, so in that case here, what would be my concentration, okay, of the one here? But of course here you need to find the one reacted lah. So in this case here, how much of HCl reacted? Now originally, here it's a bit wrong. Sorry about this. Number of moles of HCl, right now, of HCl reacted, okay, will be M1V1 over, let me see, I stop this for a while so that I can do it easy, okay? Okay, I made a mistake, so I correct it already, okay? So remember the amount of HCl in 60 cm cube, right? That means before I add the ammonia is 0.006 mole, okay? 60 cm cube times 0.1 molar, okay? This one is the one here. Now, amount of HCl reacted, of course, 0.004 because the amount of here, the amount of ammonia here, right? Here, okay, number of moles of ammonia equals to MVO1000, okay, it's equals to 20 times 0.2 or 1000, which is also equals to 0.004. So the same number of moles of HCl, so is the number of moles of HCl reacted. So the number of moles of HCl unreacted is 0.006 minus 0.004 equal to 0.002 moles in the total of how much? 80 cm cube, isn't it? 60 here plus the 20 in from here. So 60, 80, isn't it? So here is 80. So 0.002 moles of HCl in this 80. So what's the molarity? 0.025. You pH it is 1.6. That means at the end of the titration at 60 cm cube added, the pH is about 1.6 here. Okay, so I got the pH in the beginning, right? I got the pH here. But this question they ask you, later they'll ask you. Okay, so and I got the pH jump here. And I got the end point is 40. So I sketch. Okay, here, remember here is a flattened out one. Must always remember what's a buffer solution. Why? After okay. Then the jump here, 7 to 3 now. Why 7 to 3 and then go down here? And see, okay, here. Okay, so this is a graph here. Now, why is it a buffer? Because I told you already, because it is in this point here, there's excess ammonia reacted, and here so is the salt of the weak base and the strong acid. Yeah, so this is all there, but it's halfway. That means it's excess here. That means this is a buffer. That's why the pH doesn't change much here. Okay. So now this is the graph. Now let's see how the marking scheme is. Remember, there are 4 things to remember. What's the volume of the end point? pH beginning, pH at the end, and pH of the pH jump at the end point. Okay. Of course, then you have to memorize 3 to 7. Okay. So now here, of course, the indicator use, of course, metal orange was 3 to 4, right? Here, so 3 to 4 here. So it's between this range, right? So metal orange is the key. So you see now, end point here, 1 mark for 40 cm cube. Okay, shape of the curve flattish. See, shape like flattish here. Okay, not like that. Wrong. Must go down continuous. Okay, and then right flattish down. Okay, start at 11.3. That means this one must be short. 1 mark. Okay, end point here 1 mark. Okay, and then end. Okay, I start the shape of the curve 1 mark. Right. So shape of the curve 1 mark. It's 1 mark. 1, 2, 3. Now here they didn't tell you, but later you can see here they actually ask afterwards. Okay, it's 1.6 here. Later they will show you. Okay, so as I said now, of course here, remember equivalence point is about 5, isn't it? Why 5? Strong acid and weak base. Remember, see, it's not 7, right? Okay, next one. Now here, sulfuric acid is a strong dibasic acid. So dibasic, they tell you already, right? 2 here. Organic acid guanine contains carbon, blah, blah, blah. And of course, they say only one. Now, they didn't say H2SO4, no, so you must be careful here. Not one, it's a H plus here. So this is the graph for this one here, not for H2SO4. All right, so plus 1 mole, 1 mole is 1 mole, BH plus represents the molecule of guanine. Okay, so when 25% of the dilute acid was saturated against the curve, which means here, if you want to draw here, I didn't draw that one, here. Okay, so what is here? At the beginning, here's your acid here. So here's your H2SO4. Okay, and here, of course, as you're adding here is a guanidine, rather. Okay, the guanidine, the B. Okay, here. Okay, right. So here, H2SO4, the volume V1 is equals to 25.0 cm3. Right. So titrate against solution of guanine here. Okay, so that's all that's given in the beginning here. They give you blah, 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 and they draw for you the graph here, they draw for you the titration curve. Okay, is guanine a strong or weak base? Of course, it's a strong base because it goes to 14 at the ending point. Means excess of guanine added, it goes to 14, about 14 here. Okay, so pH is 14. Okay, strong base because pH is about 14 after end point. Right, you can see here the marking scheme. Okay, strong because pH is about 14, okay, no, it's lower, a bit lower than 14. Okay, because the dilution factor. Okay, the pH at the start, to tell you, here the start here is how much? Because you can see, so the one is pH is how much? pH is 0.7. Very important. That means it's the initial concentration of the H plus ion. H plus, so hence calculate the concentration of H2SO4. So log, okay, pH isn't it? So H plus is equal to 0.2 moles per dm3. That's what H plus. But what H2SO4? So this is, remember, this is the equation, okay? 1 mole equals to 2 moles because the dibasic acid. So here's the H plus. So H2SO4, half lah, no? 1 2, isn't it? So this one here. So 0.2 and 0.1. You see the marking here. Okay, so it's 0.2 and 0.1. Because H plus is 0.2, H2SO4 is 0.1, half of that. Okay, so now here, all right, then here, calculate the concentration of guanidine, in moles per dm cube. So remember, use the equation here. Right, so of course this one here, 1 mole to 1 mole. Now, can you find? Of course, you find the known to unknown, the number of moles of H plus, right? The molarity given, you found here, molarity, H plus, not H2SO4, no. Okay, the volume used is how much? The volume used is 25. Why? Because they tell you. Okay, see here, 25 cm3. Okay, right? Don't care, it's acid. Okay. Right, so the number of moles of H plus used is this one here. So 1 mole to 1 mole, that means the number of moles, right? The number of moles of your, the number of moles. Hold on a minute, something is missing here. Stop first. Okay, I may have missed it earlier there, but now my here this is correct, but I put something stupid here. Okay, so 0.2 because the molarity of H plus is this one here, 0.2. Okay, times the volume is 25. Over this is 0.005. It means the number of moles of H plus equals the number of moles of guanidine. Okay, now this number of moles is found in what volume of the guanidine used. From here you can find is 34. Why? Because end point. No. Okay, so you need to find from the graph, you use the ruler, otherwise you get wrong. Okay, so 34. So this number of moles, 34, you can find here, right? Molarity equals to what number of moles over volume? Yeah, right? Or 1,000. This is 0.147 moles per dm cube. So here 0.1 moles. Okay, allow the range. Sometimes you can plot a bit out of this method, so they allow the range, the window of error there. All right, sorry. Okay, so the last one here. Right, so now this is guanidine concentration moles per dm cube. The guanidine solution contains, this is grams per dm cube. So use the answer to calculate MR, very simple. I told you this is the common question. Yeah, you can use this, you can use other ways. Okay, concentration grams per dm cube is the moles per dm times MR, so you can find blah blah blah, and the answer 59.05. Okay, 59, okay, 0.05 doesn't matter. All right, so this is how it come out. Next one here. Now here, with this, the idea already the pH of this weak acid, chlorothalonic acid, is 1.94. Because we're going to use this to plot. Okay. Now here's the question here. The following axis sketch titration curve you obtain from 20 cm³ of 0.1 molar of NaOH is added gradually to this. I mean, this is in your, this is here right now. So you draw a diagram better. Now, so this is 10 cm³ and 0.1 mole per dm³ of acid here. This is a total added, but doesn't mean that this is the end point. No, see, you gradually added 20. So the add inside here, so decided to put 20 here. Okay, that means it's excess here, right? So then they say, okay, sketch the graph. Remember I told you 4 points, 1 end point, volume. Okay, now 2, right? pH beginning. 3, pH end. 4, pH range at end point. Okay. Sometimes this one they don't care, but sometimes they ask you to calculate. Okay, now so you don't care, that means you can put any amount they don't worry about. Of course, it must be reasonable. Okay, so now let's go to the end point first. Right now, this is the equation. Yeah. Okay, equation here. One more, isn't it? Yeah. So the volume of this originally is an acid, isn't it? Okay, so 10 cm³. And volume is it? So I put down here. Yeah. Okay, so of course here, one more here. Now this is of course the molarity of the NaOH also same, 0.1. Okay. Obviously, to be same, this must be the end point. Okay, so at 10. So at 10, so I know it's 10 already here. Okay, so at 10, so this is the end point here. So I draw it now. Draw up here. So this is the end point already. Right? So do I know the initial one? Yes, 1.94 isn't it here? Okay, now there's a weak acid and strong base in it. Okay, now, right? So now I know that I must start here, right? Now, to here the pH is what? 7 to 11, because weak acid, strong base, 3, 7, 11. So this is the one here. So now I want to find the end. Okay, the end of the whole thing. Wait, I just want to check first. I made a silly mistake just now. I don't want to make a mistake again. Okay, I rub off the error already. Okay, now again here. How to find the end, the pH at the end point at 20? Okay, now, right? So, okay, now, if you use this one here, number of moles of NaOH for 20 cm³, that means before you add any acid, okay? Is equals to what? Is equals to MV per 1000. Yeah, okay. So now this is the volume 20, right? It's a molarity of 1000, 0.002 moles. Number of moles of NaOH reacted, of course, is a 10. So volume is 10 times 0.1, all this. So this is reacted, this is the total used. That means unreacted is minus equal to 0.001. In total of 30 cm³, because of 20 of NaOH plus 10 cm³ of your acid, isn't it? Yeah, here 10 cm³. That's not. So 10 plus 30 give you how much? 40. 10 for 20, you are 30, isn't it? So it's 30 cm³. Okay. So the molarity of NaOH is what? 0.001 over 30 times 1000. So it's equal to 0.00332, blah, blah, blah. Okay. So this OH minus, now to find the pH, of course, you use ionic product of water, and find from here is 12.52. You can look over again later with your YouTube, whatever. Okay. So I know that here it'll be 12 point here, around here. Okay, here is it. Okay, around here. 12.52. Okay. So remember, start to plot the graph, I must have the end point, which is 10. So I draw a line up here, 10. Okay, I can draw right up here. Dotted lines can. Now the beginning is 9.194 because you found earlier. Okay, 1.94 we done it earlier already. And at the end, at this here is about 12.5. So here. And what's the pH jump? 7 to 11. 7 here to 11 here. So you draw now. Remember, it's a weak acid and so on. Because here the buffer area now, right? So you like curve up and flattish here, and then rise up again, and like that. Okay, whatever here, don't care. Okay, so here the buffer solution. Why is the buffer solution halfway? Remember, halfway 5. Here's the best now. Okay, here, right, where the constant of the acid, the weak acid equals to the constant of the salt. Okay, the buffer zone here. Okay, so all right. So now the answer here, you can see the marking scheme. Right, we did over this just now. Okay, so pH, started pH is Okay, now 1 mark is this. Here 1.9, okay, 1.94, 1 mark here. Second mark, it goes up, up here greater than 2. Okay, up here is greater than 2, 1 mark here. Okay, before the steep portion. Steep portion at least 3 units, okay, 3 units, okay, 7 to 3, so 3 units in, 3 units. Okay, right, at this one here, 10. See, so 1 mark. And flattens off at 12 to 13. They give marks off, so 12 to 13 here. Okay, yeah. Of course, it's not here. It's supposed to be 12.5. Okay, 12.5. So here doesn't matter as long as it's somewhere here. Okay, right. So 3 marks for this thing here. The next one here. Okay, the next one is a bit special. This is a dibasic. Okay, it's a dibase. Okay, 2 of them HCl. So we did this already, 1 by 1 more. Okay, if there means there are 2 endpoints here. Okay, remember we did this before. The day, remember here, there. Okay, right. Then deal with the first one here. Then second one here. Then finish here. Deal with the second one here. So there are 2 endpoints. Okay, number of moles, so the volume is the same lah. Right. 10 cm cube. 0.1 mole per dm cube of the G at pH 11.3. The site is starting here 11.3. Okay. Okay. When 30 cm cube of HCl, which means this is here your conical flask here. Here is your base, your G. Okay. Right. The volume here. Did you get the volume here? Added to 10 this here. Right. So it's good to put here V1 equals to 10 cm cube, M1 of the base equals to 0.1 mole per dm cube. And here's your acid. Okay, acid here, your HCl. All right, molarity here 2 is equals to 0.1. Your volume, total volume, see total volume 30. Of course, it's a lot. 30, the total volume. Total volume. Okay, added. Okay. The final is the final one is 1.6 here, 1.6 here. So you graduate it around here. Okay, so now sketch the graph. All right, so you know that here you must be you must be aware. Sadar, no, you must have 2 endpoints. All right, so one at 10, one at 20. So put the thing here. Okay, 2 here. So remember, it goes down. All right. So anywhere along here, okay, I know it's hard. So it's just too bad. You just have to learn the different kinds. I got in my notes, okay, here and then go down again here, okay, 1.6 here, okay, whatever is 1.6 here. Okay, marking scheme, all right, marking scheme here starts at 11.3, finishes at 1.6, 1 mark. Okay, so this you must show this value here, and this value here must show because they give it the value. Okay. And then what? The second point, steep portions are at 10 and 12 because there are 2 endpoints. That's all. They don't care the exactness. Okay, this one is you want to see whether you know what there's 2 endpoints. You can know my notes. There are points with 3 endpoints. There are carbonate, iron. Later we can talk about it if you want to. Okay, I won't talk about it now. Okay, right. The next one is piperidine. Remember, this is only one base. It's a mono base. No, this plus HCl. You get, of course, your this thing here, and here H, and then H here, and positive dot Cl minus. Okay, 1 mole to 1 mole. Okay, so this thing here, blah blah blah. So 20.0 cm cube of 0.1 mole of HCl was titrated slowly added to this one here. It means this one here, this is your piperidine. Okay, is in here. So the volume here is 10. Molarity is here 0.15, and then this one is added 20. Of course, this is excess. Okay, so here is 1 molar only. This 20. Obviously, this is more. Okay, so what is the whole thing here? Current number. Now here is where they teach you the total molarity at the end point. This one is the question here. Okay, so the number of moles of HCl remaining at the end. It means you gotta find total added first. Total HCl. Okay, how much you added? 20 cm cube of this one. Okay, so for 20 cm cube, how many moles of acid is there? 20 cm cube and 1 molar, so it's 0.002 moles. Okay, now number of moles reacted with the base. First of all, you find the number of moles of base first. Okay, and it was 1000, 15, 0.15 times 10. Okay, right. So the number of moles of base is this one. Of course, that means that 1 to 1. That means the number of moles of acid is the same, same thing, right? So this amount reacted. This one is the original. This is the total amount here. So how much is being remaining? The total minus the reactant, okay? Which means 0.002 minus 0.015. Means how much remainder? 0.00. I first I got it wrong. No, 0.0. That's what it's 15, right? 0.0. You bring this over here. 0.00. So 3 zeros. Okay, if you see, I got it wrong at first. I'll tell you because so many zeros. So hard to 1 0 here, 1 5. Okay, your minus of is 5. No, it's 3 zeros. If I can make mistake, you also can make mistake. Okay, so this is the amount of number of moles remaining, right? Now this number of moles are remaining in what volume? The total volume is what? 10 plus how much? 20. So in 30 cm cube. See now. So to find the constant of H plus now, right now, of H or HCl is the same thing. What's the constant of HCl? Right? At the end, so remember now, okay? Now here, molarity is equals to what? Remember? N over V, number of moles over V, because you get N equals to MV, that's not. Okay, so molarity is the number of moles over volume. So number of moles is 0.0005 over 30, okay? So it's equal to 0.0167 kg. Of course, the same as the constant H plus. Okay, right? So remember, so remember it's over 30, so the pH is equal to this, like you can solve the pH 1.778. That means this is the N, this is after adding how much? After adding 20, no, here, 20. This is the end point. That's why now they actually calculate 1.78. Okay, now you can see the marking CM, okay? 1.78, 1.78. So they give mark for this, Okay, so now the plot, all right? So the starting point, of course, without acid added, the piperidine, what's the pH? The piperidine they give earlier, I think here, then here 11.9. Okay, so you must put down. You must put the value here. Put down here 11, 12, and put here 11.9. Okay, 1 mark here. Let's see here. Okay. Okay. Start at 11.9, 1 mark. See not? Put it down. Okay, vertical portion means that this is the end point, isn't it? At 15. Okay, why 15? Why 15? You got to calculate that. Okay, now why 15? You can see here. Right? You can calculate here. V1 is equals to how much? Added here 10 cm cube. M1 equals how much? 0.15. Okay, here M2, how much is it? 0.1. Okay, so what is V2? Okay, you can use the old method M1 V1. So, I don't use that. You all could do. Number moles of base is equals to 10 times 0.15 or 1000. Okay, now, yeah. Here's go to here move 1, here move 1. So it's 0. How much is that? Times 10 here is here. So it's 0.0015. Okay, now. So number of moles of acid is the same as 0.0015. Okay, right now. So this is the number of moles of acid. Now this is the number. This is the one here. So what is the volume used? Okay, remember number of moles equals to MV 1000. Okay, now so it's equals to here. Volume is equals to number of moles 0.0015 over molarity 0.1. Okay, 0.1 here times 1000 equals to 15 cm cube. It's not. Here shift 1, here shift 1, here 3, 1, 2, 3. Sorry, here shift 1, here shift 1. Okay, 1. Yeah, 1, 2, 3, 15. Okay, 15 cm cube. So the end point is 15 cm cube. Okay, so 15 cm cube. So here is it, 15 cm cube. Beginning one and the end one here. Okay, and the range is 3.7. Why? Because strong acid and we base on. Yeah. Okay. So remember, here is ammonia. Here's the buffer. Yeah. So go down straight and then here flattish. because at the end, the halfway mark here, 7.5 is the best. Okay, and go down here, and the 3 to 7 here, right? So buffer zone here, can see, go back and see that. Right, I want to finish off in time. So start at 11.9. See, 15 is the vertical point, which is the end point, and end at 1.8. I got 1.78 better still. Okay, right? Okay. Now last, I think the last one. It's not moving. Okay, now this barium hydroxide. Okay, we are finishing on time. I think so. A bit more. Now, mind. Okay. 320. I can finish on time. Barium hydroxide, complete ionized, means it's a strong base. Okay, if you don't know, they tell you it's a complete ionized. Okay, strong base. Addition of 30 cm cube or 0.1 of this barium hydroxide into 20 cm cube of this one here. Okay, that means this is isocyanate. That means if you want to draw a diagram, it'll be like that. Did I draw a diagram here? No. Okay, draw a diagram here. Isocyanate acid, we did earlier last time. Okay, so here's your isocyanate acid here. I think H, there's here, okay, is HNCO, okay, this acid here. So weak acid. Okay, the volume here, how much is it? V1 is equals to 20.0, M1 is equals to 0.1 molar, okay, and here you add what is your barium hydroxide, okay, BaOH2, okay. And the molarity here is M2 equals to 0.1 molar. And the total volume is excess, okay, 30.0, okay. Okay, so they ask you to during the blah, 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 dilution and so forth, adding the dilution, blah, 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 calculate the OH minus at the end. All right, that means this is an excess. So remember, now this is the equation here, all right, okay. Hold on a minute, I just want to check here. Okay. Sometimes I make mistake. I hurry, I make mistake. Yeah, here I use a bit different from the marking scheme. I use a simpler method. Now here, remember now, this is the equation. Right now, 1 mole is to 2 moles. Okay. So remember, the total amount is the total amount added. Total. It's an excess, 30, not 30. All right. This is the molarity, and this is the acid, this one here. So of course, this is the limiting amount, okay? Right? So of course, in this case here, if this molarity is the same as here, okay? Right? Right? So obviously, remember here, right, you get 30, isn't it? Right? So how many of these 20 is vectored? 20, of course, not, okay? Because 20 and 20, so 20 is vectored because hold on, something is missing here. Pause for a while. See, I made another mistake again. I just corrected it. Never mind. All right, now here you can see that. Okay, remember 1 mole to 2 moles here. So if it's the molarity is the same as here, okay. So if you use 20 cm cube here, here only 10 cm cube. So I use 20. Okay, 10.0 cm cube. Yeah. So right, because 1 mole to 2 moles, okay. So if you use 20 here is 10 because the molarity is the same. You can work it out yourself. So this is the one reacted. So the unreacted is 20 cm cube. Okay. So the amount of barium hydroxide unreacted is 20 times 0.1. This is 0.02 moles. Okay. And this, of course, this is 0.02 moles. Right. And of course, for OH minus, we times 2, because 1 mole of this give you Ba 2 plus, and of course 2 moles of OH minus. Okay. So I want OH minus. So 2 times 2 times here, and in the total volume of how much? 30 plus 20, which is here 30 plus 20 or 50. So of course here 0.004, 20 here. Now this is the calculation here. So 0.04 over 50 times 1000 here is 0.080. The answer is 0.080. Yeah. Okay. Well, yeah. Okay, here, where is no here? Here. 0.080, where is the answer here? Okay, here. Okay, I put here wrongly. Let me just redeem myself. Okay, right. Now let's go to here. Right, now this is the concentration, right, of OH minus. Okay, so calculate the pH at the end. So, right, remember this is the OH minus, right, at the end, when the excess added. So use your KW, right? So because the 14 bring here, down here is the concentration of OH plus is this one here, OH plus here. Okay, it's 1.25. The answer here, 1.25 here. Okay, 1.25 here, right? 10 to the power minus 13. All right, so here's the answer. Okay, right. So the pH is, of course, you do the log thing is equals to 12.9. Okay, so 12.9, 12.9. Okay, right. So here, of course, I made a mistake here. Better rub it off. Malukan saja. Okay. Okay. Never mind. Mr. Lai, not very smart. Very clever. Okay, here we are. All right, so plot the graph. All right, so remember, you need to know the end point. End point is 20, isn't it? End point, wait again. Malukan saja. Yeah. Okay, I rub off the mistake already. Okay, sorry about it. One spill over the other. Okay, now to plot the graph, of course, here starting at what 12.9 at 2.5 because originally it was 2.5, isn't it? The acid, see now, the acid here, where is the acid? 2.5. See, I put down here. Earlier we calculated 2.5. Okay, so start here 2.5 or 2.46, 2.5 here. Right, 2.5 here. So this one here important. Now the end point is 10, isn't it? I put 20 as now, it's right, wrong. Yeah, so I correct myself. Okay, yeah, right. Remember, it's weak acid, strong base. So it's 3 to 11 is not, 7 to 11 not. Okay, so 7 to 11 is a pH jump. Of course, at the end of the thing is 12.9. Here, 12.9 pH. Okay, at what? At 20. Okay, so 20 is 12.9 here. Okay, so the pH jump is here. So you draw like that. Remember, here's a flattish. Should be more flat. Okay, I made a mistake again. Hurry. What time catching up? Okay. So make sure you know how to draw this, okay? So flattish up, flattish, and then go up. Okay, so here's the buffer zone, right? 5 is of course buffer zone. Okay, so now, okay, I've done already except for one more here. This is another a simple one. Okay, of course this is the can do for yourself. Okay, this is the weak acid and strong base out here. Okay, where the pH jump is 7 to 11 here. Okay. So the weak acid start from 5.5 here, goes up like that. Okay. Right? So you can try for yourself this one here. Okay. So I finished all already. So the next one we go is to the second part called the KSP. Right? So sorry for a lot of mistakes I made today. I don't know why I made so much mistakes here. Okay. So now mind. So you can see that it's not easy. Okay, bye-bye.